subtract 8 from both sides. Negative 3/8 k equals negative 12. Multiply both sides by negative 8/3. K equals positive 32. If you solved it by multiplying everything by 8 to clear the fractions, it becomes 64 minus 3k equals negative 32. If you subtract 64 from both sides, negative 3k equals negative 96, and k equals positive 32. Add 5/10 to both sides. X divided by 7 equals 3. Multiply both sides by 7. X equals 21. If you multiplied everything by 7 to clear the fractions, becomes x minus 3 5/10 equals 17 5/10. Add 3 5/10 to both sides. X equals 21. Add 6 to both sides. B divided by 3 equals 4. Multiply both sides by 3. B equals 12. If you multiplied everything by 3 to clear the fraction, this B minus 18 equals negative 6, or B equals 12. Add m to both sides. 1 equals 6 minus 5m. Subtract 6 from both sides. Negative 5m equals negative 5. M equals 1. Add f to both sides. This is like 1f. So this is 2 4/10 f plus 1 1/10 equals 8 3/10. Subtract 1 1/10 from both sides. 2 4/10 f equals 7 2/10. And 7 2/10 divided by 2 4/10 equals 3. This one you can multiply through by 4. Half of 4 is 2. 4 times negative 3 is negative 12. 4 times 2 is 8. And 4 times negative 3/4 is negative 3k. You can add 12 to both sides. It becomes 2k equals 20 minus 3k. Add 3k to both sides, and it becomes k equals 20. And that's not right. If you add, the mistake is right here. If I add 3k to both sides, I get 5k equals 20, and k equals 4. Distribute for number 7. 6 plus 6j minus 4 equals 4 plus 4j. This side is 6j plus 2 equals 4 plus 4j. Subtract 4j from both sides. 2j plus 2 equals 4. Subtract 2 from both sides. 2j equals 2, or j equals 1. Number 8. Distribute. 16 minus 4w equals 6w plus 6. I can add the 4w to both sides. 16 equals 10w plus 6. If I subtract 6 from both sides, it becomes 10 equals 10w. W equals 1. Consecutive even numbers means that x plus 2 plus x plus 4 equals 48. That's 3x's plus 6 equals 48. If I subtract 6 from both sides, 3x equals 42. So x equals 14, and the numbers are 14, 16, 18. So Jung has 92 coins. This is 8 more, so 8 plus 3 times the number of quarters he has. If I subtract 8 from both sides, it becomes 84 equals 3q, and if I divide both sides by 3, it becomes 28. On this one, if I distribute, it's 2x equals 2x minus 6. You might notice that that can't be possible, so there's no solution. Over this one, the easiest way is to multiply everything by 8. The 8 will cancel out here, and the first side will be 3d minus 2. The 4 will cancel with the 8. It goes twice, so the other side becomes 2 times d plus 5. If I distribute the 2, I can subtract the 2d from both sides, and it becomes d minus 2 equals 10. And if I add 2 to both sides, d equals 12. Over here, I can distribute the 5. This is plus 5q plus 4 equals 5q plus 11. And this side simplifies also to 5q plus 11. So they are both identical, and that means that all real numbers will make it true. 2 consecutive numbers are x and x plus 2. So 6 times the larger one is equal to 3 times the smaller one. This becomes 3x equals 6x plus 12. If I subtract 6x from both sides, I get negative 3x equals 12, or x equals negative 4. And the one right after negative 4 is negative 2.